So, hello. This is my Arduino driven guitar tuner. So, my problem was there weren't really any cheap automatic guitar tuners. So, what I wanted to make is just that. This is relatively cheap compared to all the other things. For something like this, might run me to make about 35 bucks. And buying a normal one off the internet would just cost me about 50 $55. uh
So this is the code flow chart. So we start and we have our frequency input, which is being gathered through our microphone, which is running through something called uh, autocorrelation, and it's a very interesting bit of code that I hope to go through in a later part of the video. So we first start with the button state being equal to 0 and string state being equal to 0. Which just means we're always starting at the electric and acoustic guitar side, and we're always starting on the low E string. Um, so if we detect that the button state, which is our buttons one, button state is controlled by button one. So it's on a input pull-up um, system. So if it reads high, then it's gonna change from its starting state, which is 0 to 1, which just means it goes to our bass guitar state. Um, and from there, like if you hit the button for string state, which is button 2, it goes from string state 1, which is your, what's it called? Your E string. Then it goes, and then you press button 2 again, it goes to your A string, then it goes to your G string, and then it goes, your D string, and then to your G string. Um, then over here, where we start at, we have our starting thing. So basically, what happens again if you hit button 2 is it goes from low E to A to D to G to B and then to high E. Um, and then this is if it's between a certain set frequency, with 52 being the lowest possible frequency the low E string can be to, and 81 being that range in which we want to be at 82 hertz. And having the higher end be 110, being the next string, the next tone, that the next string's tone to be at the standard tuning. Uh, and again, it just repeats this. So here we're shooting for 110, give it a 1 hertz tolerance, just so we can really not super overwork uh, our step motor and have it not always be as good as we want it. Like I showed in the video, this gives us it almost perfect every time. So this is the most important part of this code. This is what is allowing me to read the hertz I'm getting from the microphone, my A0 pin. Basically what's happening here is it's making a sorry, hold on. It's making a sine and square wave. It's making a sine wave from my uh, what's it called? Analog pin, my A0, and it's making a square wave with just the information about where the sine wave is at its lowest to its highest, from its trough to its peak. So it's making that square wave, and then it's calculating uh, that period to give us our frequency. And that period is set off of this timer. Really, this is the most important part of this code, and I have to really thank this person. This is where you can find this code that I grabbed from. And this isn't even their apparent best type of the code. I just used what I thought I could work off of. Anyways, that should do it. Cool. But from here, this code is like extremely simple. It's a bunch of if statements, and um, it's not really all that crazy. Uh, so really, this is the most complex part. I didn't even know where to start for this, and I'm very thankful for that person for making this code. And that should do it for this code segment. The model of what I was speaking about. This is the main body. This is the what houses the stepper motor, and this is where the peg tuner device sits up in here. Is just an exploded view of it.
So here's the actual close-up of the Arduino. Here's my Arduino Mega. I'm using this to have the pins and the, what's it called? Processing power to actually run the code and have it read what I need it to read. Here's the connector for the 9-volt battery system. So my potentiometer here, not super important, but it's pretty important for this if you don't want to go and modify put up some resistors for your LCD screen here. My LCD screen just gives us basic information about certain parts and things about the entire system and what the frequency is and what string you're trying to tune. Here we have the microphone where we record the frequencies from the guitar. This one's not the greatest, but it works for what I need it to do right now. And then I have my extra long wires here that go all the way up to my step motor board, my stepper motor. This right here is just the thing used to sit around the tuning peg to actually turn the tuner, the peg, for this automatic tuner to work. And it just kind of slides on right here. And this is the stepper motor. And I really wanted to make this for people who like struggled with like tuning their guitars. And so I wanted to work on both my acoustic, my electric, and my bass guitar. So basically it says hello tuner. Then you can use these two buttons here. If you hit this first button, it changes it from guitar to bass guitar. And you can switch back to electric / acoustic with that same button. With this button here, you can switch between strings. In future iterations, I'd like to have it to have a casing that holds basically this Arduino and all this, and like this on an extended thing that can like slide out from under the main body, so that this can go like to your headstock. And I want it to still be programmable while also running off of a 9-volt battery system. It works by like having this tuning peg module right here, the peg tuner or turner or whatever, and this actually slides right on to the peg here. Here's it going on to the peg, and then it turns counterclockwise to turn the peg that tuned it up, and it turns counterclockwise to turn the peg down.